Da 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 da. All right, here we go. So, you may or may not have seen one of these in previous videos. I'm literally doing a lot of holes in them, and customer wants to have these at maximum surface quality. So I already prepared those blanks. Those are gonna go on op 2 on the CNC lathe, and yeah, join me in this process. So yeah, this is op 2 on the parts, and as you can see, you can't see that much, but let me tell you, it is doing
The thing goes
and then it's doing
boom.
and at the end
You don't know.
we're gonna end up with this part. Alright, so now we're gonna go to the drilling part, and this is where I had problems in the past. So the part is already set up in the 3-jaw chuck, is centered and picked up work coordinates. And as you may know, the Maho is a great machine, but one thing it lacks is its function of the spindle through coolant. It unfortunately doesn't have that option. This is kind of a small collection of drills I gathered around the years of making this product. And all the drills I've tested range from solid carbide to high-speed steel. Different coatings, different speeds and feeds, and I do have very little success with these. I couldn't get any solid carbide drills to work. This was my go-to drill actually. It is a high-speed steel. The high helix angle gave it its properties of getting the chips out of the bore with just flood coolant from above. That drill did somewhere in the range of 1500 bores. For comparison, without spindle through coolant, a solid carbide drill would only last a few holes, just because I couldn't get any coolant down in the bore. So that's what we're gonna change today. So we're searching for a solution to do these holes with a lot more speed and feed, and I came across these guys. This is Rego Fix and their Recool coolant system, and what this allows you to do is just use your flood coolant as an input on here, and it's gonna, with the revolving tool, it's gonna squirt the coolant through the drill, and I can show you how that is working out. So basically you can use your every standard ER style collet holder. I'm gonna be using a solid carbide 4.8 mil with spindle through holes made by Göring. This is the special nut that Rigofix sells for ER32 holders, but I guess they have them in all other sizes. And this is a blocking plate for a 6mm tool. So you mount a standard collet in here, then you put in your tool, make sure that this 6mm shank is in contact with that O-ring, and just gonna screw it on here like you would with any other collet nut. There's a special tool. Alright, it is tightened, and you can see that this is still rotating, and what you just do is hook this pneumatic air style fitting up to your flood coolant, which I will show you later, and then you have cooling coming out of your drill or other tool. So yeah, this isn't awfully much of a coolant spray, but also keep in mind this is not a high pressure pump. so it's really having problems building up enough pressure in that really small channels of that sub 5mm drill. But I'm running quite high surface feeds and speeds, so it is holding up awesome. The last drill I did with this made around 1500 holes. I had no damage on it. Alright, so the drill ran through the first part, and as you can see, the chips do look pretty nice. They're short, all consistent, no discolored ones, so I guess we're running pretty consistent here. The hole diameters also check out to be perfect. They're 4.8 mil, and next up we're gonna go with the reamer that reams 5.0. When you're running such a process, make sure to have an M0 programmed somewhere, because if the tool changer is gonna grab that tool, well, something's gonna break. So the next tool is a reamer, also made by Göring. This one happens to be a 5H7 with, I guess that's the nano fire coating. That is the internal surface finish after reaming, and as you can see, all in all the quality is quite good, but there are a few inconsistencies, like in this hole or this one. That may be from feeding the tool out, and often these reamers leave marks that are visually they're kind of big, but if you go in there with a measurement, you will see that it's mostly optical. But we have to go even further and make this surface as good as possible in a CNC process. So that's why today we're going to test out a roller burnishing tool from this company. So the shank can be bought separately, also the tool, and this will accept different diameters. So what this does, those small pins you can see are from solid carbide. And by twisting this, you can adjust the pre-tension on the tool. So you basically just feed it into the pre-existing hole through this bearing. It may turn, and it's gonna do a cold working of the surface. So it will eventually, with this kind of big radius on top of here, it will smooth out all the marks from the previous operations. So we'll see how that turns out. So I've ran the first few, these 6 here. You can see there's still some marks, but it improved. So what we can do on this tool, there is a scale ring. You can see that here. There are divisions on here. And by twisting this or screwing this, you can dial in. Each of these lines is equal to 1/100th of a millimeter. So I dialed in another 100th, and we go again. I did the back half. Front half is still reamed surface. I don't know, the camera won't pick this up, but this one has certainly the grooves you can feel with a pick. On this one, it just slides over there without any burps or anything. But we have to check when we can take this out of the chuck. So let's run this to the end and have a look. Alright, so this is an older version after already some abuse. Also, you can see it will eventually get coated with vapor deposition. This is also not really cleaned thoroughly. So this is the old one. And this is what we machined a few minutes ago. This is looking absolutely awesome. Check that out. Alright, so that was a major success. I didn't really know what to expect from this burnishing tool, but it turned out awesome. The surface quality is just impeccable. And yeah, these parts go to surface grinding now, and then they're being coated just like this one. So I hope you found that interesting in being in search of perfect surface finish in these holes. And yeah, see you next time. Bye.